Okay. In the previous class that we had, we've managed to talk about the area, the applications of the volume, also the calculations of the volume there. We managed to talk about it, which was so much important because this part now is a continuation. But it is not going to be on the volume. No, it's going to be on the area. So you wonder to say, the areas that we were calculating in the previous class, in actual sense, we never calculated an area, we just talked about the area. That part of area that we talked about, how and where are we going to use it? We are going to use this application in the calculation of what we refer to as the centroids. A centroid, which is being taken from the area moments. So you are going to see, I think this is supposed to be page 5 of your formula sheet. We have got the area moments and also how to calculate the centroid. So these two, they work hand in hand. You need the area moment in order for you to have a centroid. So if I'm going back here to explain about this, how to use these formulas later on. All right. Remember, we had the centroids in engineering science N4. The application of centroids, just like what we had in that science N4, it is the same thing like what we had on the moment of area. The moment of area. We've got the same thing. What am I trying to say? In order for you to determine a certain centroid or whatever distance that you're given them, you have to consider the condition of each shape. Is it a triangle? Is it a rectangle? Is it a square? You have to consider all those things. That's the same thing even in the moment, even for these ones in maths. Each part, we are going to consider each condition as we know that, all right, let's talk about this. The moment of area, it is simply talking about the product of area. So this one we simply have is the product. I'm gonna explain this very soon. The product of the area. So it's gonna be the product of the area and the perpendicular distance. And the perpendicular distance. Perpendicular distance of its centroid, perpendicular distance of its centroid. All right, so you're gonna consider its centroid there, of its centroid from the axis of rotation. All right, so this is gonna be taken from the axis of rotation. From the axis of rotation. So this is what I want you to bear in mind. Let's say we've got a diagram like this. Let's say we've got our y-axis and x-axis, which is our Cartesian plane. All right. You are going to notice that in terms of our distances, when we are saying from the axis of rotation, if the rotation is x-axis, the distance from the x-axis from this x-axis is this one, which is we're talking about the y. If you're talking about the y-axis as the rotation, the distance is this one from the y-axis up to this point. This is the distance that we talk about. So together, you obtain a point, which is your centroid point, given as x bar, y bar, like that. Representing what? A centroid. So whereby, as we can see, or as we can conclude from what I just said, I simply said this x bar that we are talking about represents the distance from the y-axis. So this is the distance from where? From the y-axis, the distance from the y-axis. What about the y bar? The y bar is the distance from the x-axis as we are going up from that x-axis. So this is the distance from the x-axis. The distance from the x-axis. Okay, with this knowledge, you are going to notice that since we say the area moment in this case, area is the product of the area. So let's say I'm referring to the area moment about the x-axis. We are going to see that the area moment about the x-axis is going to be the product of the area times the perpendicular distance of each centroid from the axis of rotation, from the x-axis. So from the x-axis, which one are we considering? It's y bar. So meaning to say the area moment is going to be taken as area times y bar for the x-axis. So what does it mean? It means if I have got the area moment and also the area, I can calculate this distance from the x-axis, which is y bar. So it follows that y bar is going to be what? If I divide this by the area here, I divide by the area, I'm going to have the area moment over the area. So meaning to say I'm going to left with the area moment for x over the area. That's the same thing even for the area moment, considering for the y-axis area times what? Perpendicular distance from the axis of rotation from the y-axis. So from the y-axis, which bar are we considering? We are considering x bar. So that's x bar. Therefore, this can be calculated. So therefore, our x bar is going to be the area moment for the y over the area that is the area that you have calculated before. So the question is, all right, this area moment that we're talking about is measured in cubic units. Area moment is measured in cubic units. So it's going to be cubic units for area moment, square units for area. So it means this will be in units. The distance is just going to be units, all right? That is the idea there. So, like I said, that this is not important, guys. This is not important for now. You have this because you have got this in part here. Okay, I'm actually having the formula here. The area moment, you're gonna see these formulas that you have here. We're gonna talk about this RDA, this and that. So if you take note now, because we now have the formula that we need. To calculate x bar, I need area moment for y. To calculate y bar, I'm going to need area moment for x. So that is where now we have these formulas in the calculation of the area moments. The area moment for x is going to be RDA. The area moment for y is going to be RDA, which is the same thing. But these two, they are different. These two, they are different. If they look the same. So this type of a question is a conditional question. So you're going to conclude that part later on. So this is the same thing that you're having here, the centroid for x, area moment for y over area, centroid for y, area moment for x over the area, which are the same areas that we calculated here. So meaning to say for the same thing, just like what I had here. So you're going to see that these are that we are talking about. Let's talk about this part here of the area. The area moment there is controlled by two things, which is R and the dA, which is the area expression. So dA represents area expression. Area expression. So you're going to see that the R that we are having there is the most important one. For all these ones, it's just going to be a representative strip. For all these second moment of area, the volume moment, this R is just a strip. It's just a strip. But on the area moment, on this one, on the area moment and the centroid, it's not like that. It's true that it represents a strip, but you consider the strip according to the function that you're given, the type of function that you have. All right, let's say, let's talk about this R. Let us just talk about what determining the centroid. All right, so the centroid I'm just going to present as G, which is XY. Remember, that is, we're supposed to have the X and to have the Y. But it is controlled now by the function that you're given, or the condition of the function. If you are given a condition where Y is equal to f of X, let's say I've got Y is equal to f of X, between this and the x-axis, I consider this and the x-axis. And the x-axis. So the function of Y is equal to f of X and the x-axis, let's just say, is something like this. I'm just going to present a sketch here, what I'm simply referring to. So given this function, let's say we've got something of this nature for this Y is equal to f of X. This is the function that you're considering, which is taken at the limits where this is A and this is B, the limits for X, and this is the strip for X. This is what I'm trying to say. Y is equal to f of X between this and the x-axis. Whenever you've got a condition like this, you're going to see G, which is our centroid that we're going to consider in terms of the X and Y values. The G is going to be taken as X. Then for the Y, it is going to be Y over 2. So the Y value is going to be Y over 2. So X, you just take X as it is. But for Y, it's going to be Y over 2. That is, when you're considering the x-axis, the strip is for X, like this. Y is equal to f of X, the strip for X like that. This will be your centroid G. So meaning to say your R there, this R that we have been talking about here, you are going to, if it is representing, because definitely is the strip, like I said, but you have to consider that strip. So if this R is representing the Y value, what does it mean? That is the condition. Sorry for that. If it is representing the Y value, it means we're going to take it as what? As Y over 2. If it is for X, we're going to take it as what? As X as it is. For a function of this nature. This is how you consider it. All right. If I'm having the same condition of, but let's say I've got a circle. We can have this condition given a circle. So you need to know each condition given a circle or an ellipse, or you're going to have also an ellipse. So these two, they just work hand in hand. So you're going to see that when it comes to the centroid part, this is what you're going to have. So given our circle or our ellipse, it's going to be something of this nature, let's say taken from the origin. And we are talking about the strip being for X. So the strip, we are still for the strip for X. Actually, for the circle, it's just going to be the same thing that you're going to consider. It's just going to be opposite when it is the strip for Y, how you consider your X and Y. So this is what you're going to have when it is a circle. You're going to consider your G, the X, and it's going to be Y over 2. Meaning to say, if R is representing X, you're going to take as X. If R represents Y, you're going to use Y over 2. That is the strip that you're going to, that is the centroid that you use when dealing with a circle and ellipse, which is just the same as the function of what? Y is equal to f of X. It is the same thing. But let's say we have got two functions this time. Another condition can be when you're given between two graphs. Between two graphs, still on the what? On the x-axis and the x-axis. So given two functions in this case, which is two curves, and considering with the x-axis, it means we have got something of this nature. Let's say we've got the first function considered like this, and the other function like this, and this is our limit A, and this is our limit B. So remember the condition that we had, y1 and y2, the top function being y1 is equal to f of x, the bottom one, y2, maybe it's gx like that. So this is the strip for x, because we are considering about the what? X-axis. On a condition of this nature, when it is of the x-axis, the x is going to be taken as it is, but for the y, you're going to add these two, y1 plus the average of these two functions. That is your centroid. So the centroid of this one is going to be given as x, but for y, you add their two functions this time. It was just supposed to be like y over 2. Guys, are we together here? The x is just x. It's not changing when you're dealing with respect to x. X is just x. It does not change. But y is supposed to be y over 2. But because there are two functions now, we are going to take as y1 plus y2 over 2. It's going to be the average of these two functions. So that's it. So you see that these conditions that we listed here, when we are having our centroids, they are going to be opposed when you're dealing with the y-axis. Everything there was for the x-axis. So if now we are dealing with the y-axis, which is parallel to the x-axis, that is what? To the y-axis. So on these conditions, we are going to have, instead of us having y is equal to f of x, it's going to be x is equal to f of y. Our function will be of x is equal to f of y. You're going to see that your function on that consideration is of x, which is equal to f of y, and the x and the y-axis. So we want to see what's going to happen in terms of those centroids. So this time you are considering the y-axis, meaning to say y is not going to change. It's x that will be changed. It will be x over 2, x over. So you see that is the condition now. Here it was with about the x-axis and the x-axis. So x was just x, but y was y over 2, y. But there are two functions, y plus 1, y1 plus y2 over 2. So it's the same thing like what we had. Now we are considering a function and the x-axis, meaning and the y-axis, meaning to say the strip this time is for the y, given the limits maybe c to d, and we've got the strip like this, which is the strip for what? For y. This will be x is equal to what? F of y. So that's what I'm saying. So you're going to see on this condition, your centroid, it will be now x over 2. So x is no longer just x, is now x over 2 because you're considering for what? For y. So if you're considering for the y-axis, the y is the one that is not affected. Y is just going to remain as a y like that. So meaning says the same thing, just even for a circle, you consider the same thing. It means it's going to be x over 2, y there for a circle. So I'm not going to talk about that. Let's talk about when you're given two functions, just like what we had in the previous case. Given what? Two functions. Given two functions or graphs or curves, given two graphs, and still on the what? On the y-axis and the y-axis. So if you're given this consideration where this time we've got two functions, but they are being considered about the y-axis, like whatever that you're going to have there about the area moment is considered about the y-axis. So meaning to say, we still have the strip for what? The strip for y. So this is the strip for y. So our g, just like the previous case, it was supposed to be x over 2 because you're considering y. Y is not affected. Y is going to remain as it is. But x is the one that is affected. So x is going to be affected in which manner? We've got x1, which is the top part, and also x2. So it's going to be x1 plus x2 over 2. So this is going to be x1 plus x2 over 2. That is what you're going to use in place of r. In place of what? In place of r. So this, it's a conditional question. So you see all those questions that we're answering, you're wondering, why is it this question I'm using x over 2? Why another question I'm using y over 2? What's happening? Because it's a conditional question. Just like centroids in our science N4. You don't use the centroid of a triangle to calculate information of a rectangle. No, it's impossible. That is the same way. I don't use this centroid here to calculate a question which is about the y-axis. No, I don't use that. About the y-axis, about the x-axis is different. About the x-axis for two given functions, our centroid is going to be x, and this will be y1 plus y2 over 2. So is this part playing a role of knowing this? Where is it playing a role? That is the question. Where is it playing a role? Okay, we say it here. Let's consider now where this is playing a role. The area moment for x is given by this formula. Okay, so I want you to see there. I say that the area moment is given. Let's start with the area moment for x. Let's say I want to calculate the centroid of area between the curve and the x-axis, all right? Let's say I want to calculate the centroid of the area, between a curve and the x-axis. So it's going to be between a curve. Let's start with the x-axis. So if we are considering this between the curve and the x-axis, meaning you say it's a single curve. It's a single curve, that just like this one. So the condition that we are dealing with is this one, a curve and the x-axis, this one. Y is equal to f of x and the what? X-axis. So this is the condition that we have. So on this condition, what is your G? Well, what is the centroid? The centroid is x, y over 2. When given this condition of y is equal to f of x and what? So knowing that alone is enough. I have got the representative strip, this and that, my a, b, y is equal to f of x. This is my x, this is my y. This is how your function is going to be like. So we say G at that condition when it is like this. For the x-axis, it means x is not affected. What is affected is y. Y is the one that is, so it's going to be y over 2. So this is what you're going to use in place of R. So what I'm trying to say is that if you take, this is the formula for the area moment, this one. The area moment is given by what? For x, RDA, which is the same thing even for the area moment for y. So now let's make adjustments on those areas, depending with the curve. So I'm just going to do this example. You'll finish up on those other ones because what you're going to have on this one is different from another one. So you're going to see that the area moment for x, it was given by this. Area moment for x is given by RDA. This is what you're given. So what does it mean? It means the area moment in actual sense is going to be the integral of this. The area moment is going to be the integral of this part. But R now represents, take note about the x-axis. But you're considering when we just have a single curve there. So R now I said is the distance from the axis of rotation, from the x-axis. This R here. This is the distance from the x-axis. So the distance from the x-axis is not going to be taken the way that we know that, okay, the distance from the x-axis, so it's going to be y. No. What is that this here? Y, our x, this is our x bar, this is y bar. Y bar is represented by y over 2. It's y over 2 there. So it means this is going to be taken as the integral of y over 2. Remember, our limits is from a to b for the area with respect to x. This dA is the area expression. This dA is the area expression. How do you calculate the area when the strip is for x like this? How do you calculate your area? Your area with respect to x is the integral of y with respect to x, given the limits a and b. So the dA is the area expression for that strip. The area expression for that strip. So it's for the x. And what is the area expression? Y dx. So it means this formula is going to be adjusted like this, y dx. That's how you're going to adjust your formula. So you end up now having this formula where they multiply this, even take this, because it's 1 over 2. You can take 1 over 2 out of the integral. Then we are left with y times y, which is going to be y squared dx. So in actual sense, if you understand that the area moment for x, if I see it, is going to be like this, whenever I'm given a single function between the x-axis, this is the formula that you're going to use at the end. But where was it? It was taken from here. And we have to make adjustments. So what does this y now represents this y? Y here represents a function for x. So y is equal to f of x. So this y is the function of x that you have here. You square that function of x there. You're going to square it. So if you understand from this way that you're going to manipulate, to change everything, it's fine. If you understand it up to this stage, then it means you're simply going to take this formula, you substitute y. But this formula is not the same as when there are two functions or when we're calculating the area moment for y. No, it's not the same. It's not the same. It's different. So now that you have the area moment, what do we need? What do we need? We need the centroid now. So the centroid, it means you're talking about y bar. If you calculate area moment for x, the centroid is going to be y bar. So y bar, like I said before, is the area moment for x over the area. The area is the one that we calculate. Remember, we talked about the area for x from the integral of y with respect to x from a to b. So already the area is there. The area is there. The area is there. So guys, be careful there. Be very, very careful. So this was the centroid of area. The centroid of area that we are, the area moment that we focused was the area moment for x. But within the same axis of rotation, which is the x-axis, they can ask us to calculate the area moment for y. What are we going to do if they now need us to calculate the area moment for y? Guys, the formula is the same. The integral of what is going to be r dA. That is what we saw from our formula sheet. But I said it's different, even though it's the same the way that is written there. It's different. All right. We are calculating the area moment of a certain curve, which is bounded by the x-axis, but we want the area moment for y. But take note, the curve is bounded by what? By the x-axis. The only thing that is not going to change here, it is the area, because it's bounded by the x-axis. That's why I said on the introduction, area is affected by the axis of rotation. Area is affected. If it is x, it's x. So the area is still the area for x, which is the integral of y with respect to x with our limits a to b. So the dA that we are seeing there is the area expression. Still, the area expression, it hasn't changed. No, it hasn't changed. What is going to only change here is this r. If we are calculating the area moment for y, it means r, this one, is simply indicating or represents the distance from the y-axis. And the distance from the y-axis is x bar. And x bar is represented by what? By x. We are under the x-axis, so that's why x did not change, so it's just x. But y, it was y over 2, but x is just going to be x, so it will be the integral of x, which is our r, times dA. Our dA is the area expression. And what is our area expression? Our area expression is going to be y dx with our limits from a to b. So this is the area moment that you're going to use. From the same diagram, same information, but the area moment for y has changed. The area moment has changed. So as we can see here, we can't multiply like what we did y times y. This one is just going to remain as it is. But this y here representing what? Y is equal to f of x. So it means you are going to take your f of x in terms of x. You multiply it to this x. You integrate. That's your area moment for y. That's your area moment for y. So therefore, from the area moment for y, we're going to calculate x bar, which is the area moment for y over the area that you calculated here. So this type of equation, you calculate the area on item 1, then item 2, they ask you to calculate about the centroid. That centroid you have to consider from the area that you calculated and also from the area moment. These two, they play hand in hand. They work hand in hand. They work hand in hand. So that is how you calculate your your area moment. So I'm not going to talk about these guys like all these curves. There are so many things that you can consider. So what I simply need you to do is to work with more questions. So what we're going to do is to also consider when it is now between the curve, between two given curves, still on the x-axis, because if you consider here, we considered between the x-axis. So if you were to consider between the x-axis, it means for the area moment for x, the area moment for x, it is going to take what? RDA, which is the distance from the x-axis. Your distance from the x-axis is going to be given as y1 plus y2 over 2. That is your distance. If it is area moment for y-axis, your RDA, your R there is going to be x. It does not change. It's just going to be x times what? dA, which is dA is the area expression for that particular question. So we're going to talk about that. We're going to talk about that. But this was between the curve, just a single curve, and the x-axis. Using the same idea, same knowledge, or same information, you're going to apply that even for the y-axis, but I'm not going to talk about everything. I'm just going to talk about one function here. Even if we're to consider that, let's say your conditions, you are given a curve that is between the curve and the y-axis. That is what you have. You have a condition of what? The centroid of the curve. All right, let's just write here the centroid. What is going to happen now? The centroid of area. So it's of area between a curve and the y-axis. Between a curve and the y-axis. So if it is now between a curve and the y-axis, it means this is what we now have here. This is what we now have. And for the curve and the y-axis, it means the strip that we are talking about is the strip for y. So in terms of area, like I said, area always is taken from the representative strip. And what is our representative strip? Is for y. So it means the area is going to be the area for y. That one is not going to change. And the area for y is the integral of what? Of x with respect to y with our limits from c to d. This is the area expression. That's why our x is supposed to be x is equal to f of y. X is a function of y. X represents the function of what? Of y. So this is your area expression. Because you saw that we need the area expression, guys. Every time here, we're considering this one. What is the area for x? This one, what is? So we need that. So the question is now, from this curve and the x and the y-axis, how are we going to calculate now our area moment about the x? The area moment about the y? That is the question. Okay, let's start with the area moment about the x. From the same curve, this one, we're considering curve number 1. So I'm considering this one, this curve here. So you're going to see that from this curve, which is the area moment about x, because the area moment is always given by RDA, as we saw that is RDA. So it's the integral of RDA. So the RDA, what is the R there? The distance from the x-axis. And according to this, what is our centroid when it is like this? It's x over 2y. The distance from the x-axis is y, not y over 2, no, it's y. So you're going to use y there. So you see how you take your centroid. It is a conditional, it's a condition type of equation. So y there, according to this function, y is just y. It's not affected, so it's just y. Then dA is the area expression. What is our area expression? Our area expression is x dy. That is our area expression, x dy. So you're going to include our limits from c to d. So as you can see, these two cannot be combined. X and y, they're different. We can't multiply them like x times x is x squared. So what you need is to adjust so that this can be integrated. What are you going to do? Y is already in terms of y with respect to y. So y is not affected. So it means this x here must be written in terms of y. So if it is supposed to be written in terms of y, it means x is that function of y. So x is equal to what? To the function of y. So if you substitute a function of y here, you can multiply with this y, you can integrate, substitute your limit, you have got your area moment. Once I have the area moment for y, what is it that I calculate from the area moment? If I have the area moment for x, I calculate y bar. Y bar, which is the distance from this one, is going to be area moment for x over the area. The area moment is the one that you're going to calculate from this. The area is the one that you're calculating from this. So we've got everything there, which means we can calculate the distance, which is the same thing from the same diagram. From the same diagram, this same diagram where the strip is for y or the area there is affected as for y, they can ask us a condition where we need to apply or we need to use the area moment for y. Just like what we did on this one, the area moment for x. So what is going to be the area moment for y? You're going to see that the area moment for y is going to be taken from this same formula, r dA. But like I said, r is something that depends the distance from the y-axis. And the distance from the y-axis, according to this centroid of ours, the distance from the y-axis according to this g of this function. What is the distance from the x-axis? It's given now as what? As x over 2, like I said before. So we now write this as the integral of x over 2, not just x, no, but x over 2. dA is the area. It has not changed because the strip is still for y. So the area expression is still the same, x dy. So the area expression is still the same, x dy. So it means we can take the 1 over 2 out of the integral. Remember our limits from c to d. So it's going to be 1 over 2 out of the integral x times x, which is going to be what? X squared with respect to 1. So this is the formula at the end that you're going to use to calculate the area moment for what? For y. When given a condition where the curve is between what? Between the y-axis. Only when the curve is between the y, only. That is the formula that you're going to need. Otherwise, it will change. It depends because the r there is it's something that is affected by the type of function that you're dealing with. And where is it from? So you need to know every shape that I explained on the introduction part. So x bar is going to be the area moment for y over the area, which is the area is the one that we calculated before here. So we already have our area. So as you can see, that's what you're going to have. And you're going to use this information also to calculate the area moments when it is now between two curves. So between two curves, I just mentioned the centroids. How do you take your centroids when it is between the two curves and the y-axis, between the two curves or the two graphs and the x? I just mentioned. So we're going to talk about this in our next class when we consider a question. That is, we're going to explain that part in more detail. So I'm just going to choose a question which applies a condition where it is either a centroid area between the curve and the x-axis or between the curve and the y-axis, like what we had here. These are two things that we're going to consider. Let's see which one do we have on that question so that we can apply it. There we are given a function which is an ellipse. Remember, I considered also for an ellipse the condition of your centroids, whether it's between the x-axis or it's between the y-axis, is the same. Make a neat sketch of this function of that's 5.21, which is 9x squared plus 4y squared is equal to 36. So make a neat sketch about this. Then show the representative strip or element that you will use to calculate the area above the x-axis, bounded by the graph and the x-axis. Bounded by the graph and what? And bounded by the graph and the x-axis. Bounded by the graph and the x. We are here. I want you to see this part. I want you to see this part. Let's hope we're not going to affect this part here. Area between a curve and the x-axis. These are the only two conditions that we're going to expect to have. Meaning to say our G is going to be taken as what when it is like this between the curve and the x-axis. We said our g is going to be this one. X is not going to change because it's about the x-axis. That part that is this one, I want you to see here. Let's go back to our question. Here. Bounded by the graph and the x-axis, when you're dealing with centroids, this one for area moments, the centroid, it means the x is the one that is not affected. Y is the one that is affected. So it's going to be y over 2, just like that. If they say this and the y-axis, it means the y-axis is the one that is not affected, but x is affected. So it's going to be x over 2, just like that. But if they are now two different functions, now, if they are two functions that you're considering, it means it's no longer y over 2 there. X, yes, x is not going to change, but y is not going to be y over 2 because there are two functions for y. So it's going to be y plus 1, y1 plus y2 over 2. That's it. It's just like that. That's how you take your centroid. So here we have got a curve, which is our ellipse. It's a curve between the x-axis. So if it is between the x, this is the condition that we're going to use. X is not affected, but y is affected. And it's just a single curve. So it's just y over 2, just like that. Just like that. That is the condition. The question there is, it will be affected later on. Let's talk about the centroid first. The centroid there, they talk about it, about the x. This one is another thing on its own. Here, I'm talking about this one that you used on your calculation there in place of R. That is where you take it in. It's just a single curve. So that is where this information that I was trying to explain, this one plays a role. So if you can just memorize this, you'll see that between the curve and the x-axis, x is not affected. It is y which is affected, y over 2. Between the curve and the y-axis, y is not affected. It is x which is affected, x over 2. If there are two given functions, that part that is affected, I add it, x1 plus x2 over 2, y1 plus y1 plus y2 over 2. I mean, just like that. Just like that. Just like that. So anyways, let's see. So they are saying we are supposed to sketch this ellipse in the, and we are supposed to show whatever that we need, it must be above the x-axis. Whatever that we are going to use in our calculation must be above the x-axis. Remember our ellipse, guys, just like a circle, if you consider your x-intercepts and y-intercepts, you're done. The x-intercepts where y is equal to 0. If y is equal to 0 here, we are going to have 9x squared is equal to 36 divided by 9. So that means x squared is equal to 4. The square root, x is equal to plus or minus 2. For the y-intercept, it means x is equal to 0 at that moment. So if x is equal to 0, it means 4y squared is going to be equal to 36. So if 4y squared is equal to 36, all right, guys, everything here, it has just been affected, but I'm just gonna see what can we do. All right, anyways, but what you're gonna do is just to recall from the previous, you guys in Advantage there, you have a video, so you can even check back. But like I was saying that for an ellipse, which we are given, this as 9x squared plus 4y squared is equivalent to 36. In order for you to have this, we saw that when it is between an ellipse or a circle and the x-axis, we saw that our g can be given as x, y over 2, just like any other function. So we are going to need the sketch first because the first part there is not about the issue of the moments or what. No, it's about the function. So this part does not affect anything. You just have to show your strip and this and that, everything. All right. So you're given 9x squared plus 4y squared. These two are different. That's why we're going to consider this as an ellipse. So I said for the x-intercepts, remember I said y must be 0 there, where this was going to be 9x squared is equal to 36 divided by 9. You ended up x squared being a 4. Then x gave us plus or minus 2 from the square root of what? From the square root of 4. Doing the same thing for the y-intercept, you were going to have the same thing, x being a 0 there, meaning to say we're going to be left with 4y squared, which is 36 divided by 4. By 4 both sides, so that means y squared is going to be 9. then the square root both sides, y was going to be plus or minus 3. So guys, I'm just going to erase because if I don't, this board is going to affect us. So we need the x and plus. This is just a sketch here. This is just a sketch that you're going to have. The x-axis and also the y-axis. So that's a 0 there. So x, maybe our x plus 2 is somewhere here. And maybe minus 2 is somewhere here. Y plus 3 maybe somewhere here. Then minus 3 maybe it's somewhere there. You are going to draw, you're going to join by through the points. All right, so you're going to just join this. You're going to have an ellipse. So an ellipse is not a circle. It's just like similar to a circle, not a circle. But they specifically mentioned the part that we are going to consider, that it must be above the x-axis, above, on top of the x, meaning to say we are considering here on top of the x, between the curve and the x-axis, yes, but above the x-axis, bounded by the graph and the x, it's bounded by the graph and the x-axis, but being above. It was below. If it was below, you're going to take this one. This is the below part, below the x-axis. This is our x-axis. So with this is our function that we have, which is, we can see that the limits are for x. Therefore, the representative strip there is going to be for x, because we've got the limits for x from minus 2 up to 2. So the limit is for x. I mean, the limits are for x. The strip is going to be for x. So there we are still together there. We are still together. This is our function, 9x squared plus 4y squared is equal to 36. We are still together. But now, calculating the area, still we are together there. 5.22. The area, the strip is for x. So I said area goes together with the strip. So it means if the strip is for x, the area also must be for x. That's the area with the strip for x. The area for y, the strip for y. So we know that the area is going to be the integral of y with respect to x with our limits a to b. We also given this from our formula sheet. We give an area between the curve and the x-axis. We also talked about this in our N5. So that means the area with respect to x was going to be the integral, the limits taken from -2 up to +2, but we need y there. So meaning to say on this equation, I was going to make y the subject of the formula. 9x squared plus 4y squared is equal to 36. So I need to make y the subject, as we saw that there we need y as the subject. 4y squared is going to be equal to 36 minus 9x squared. So you can even divide by 4, by 4, by 4. So this is going to be y squared is equal to 36. 36 over 4, that is 9, minus 9 over 4 x squared. So we can clearly see that there is a square root here. There's a, all right, where is the square root, guys? All right, the y squared. Okay, sorry, guys. There's an integral here, and the integral there is of a square root, because we're going to need this, the square root of this one. So I want you to see what's going to happen, the part that I was rushing to explain there. This is 9 minus 9 over 4x squared. So as we can see, we have a square root on this case. And we are supposed to integrate this here, because there's an integral that we're going to integrate. And it's a square root. Guys, there's no term outside. This is y here. Y is this part, this one. This is your y here. Let me write it down. Maybe you understand me. That's the square root of 9 minus 9 over 4x squared with respect to x. So we manipulated from the circle that we had. We made y to be the subject here. So y is equal to the square root of 9 minus 9 over 4x squared. But like I said, this is a square root that you're considering there. You're considering a square root. You're considering a square root. which we can't integrate. If there was something out of the integral here, maybe there's an x out of the integral, at least we're going to think of the substitution method. But with this, we are stuck because we can't substitute, because whatever that we need, it cannot cancel with anything because there's no term out of the square root. So the only part that you are left with is that, if you still remember when we were dealing with, when we were working with the integration by completing of the square method, we had a condition like this, integrating something under the square root. If we check these integrals here, I want to go with you through these here. These integrals, we use them when we're dealing with the completing of the square method. The same integrals can be used on this type of equation. So if you check there, we have got an integral of something like this. The integral, it was still an expression. It was 9 minus 9 over 4 x squared under the square root like this. This is what you need to integrate. So if we are to integrate this with respect, we need a format of this nature that can be written in this nature. We need a format of this nature. So there we are given that the integral of the square root of a squared minus b squared x squared, this one, is the same thing. A squared, we can write this in terms of a number squared, this one. So yes, we can factor out that one is another issue, guys. We can even leave it like that, like this, because this is the format here. We've got this format here, which can integrate this type of equation. Okay, let me write it down. Let me write it down. You understand me? From that integral there, we saw that this integral can be given as, just hope the space here is going to be fine. We saw that if we are given the integral of the square root of a squared minus b squared x squared with respect to x, this can be given as a squared over 2b. Then we have got the x sign of bx, everything over a, plus x over 2, the square root of a squared minus b squared x squared. Then we're going to add the constant of integration. This is what we have on that formula there. This is what we have on that formula. So we need to work with this formula, with this integral, to match this integral that we have here. That is what we need. So to match this integral, what are we going to do? It's either we can even factor out the 9 over 4. That one, guys, it's up to you. Like what we had in N5. But here there's no need, because A and B, these are two different numbers. So 9 can be written as a perfect square like this one. It can be written as the square root of 9. This 9 can be written as 3 squared. Minus the 9 over 4 can be written as 3 over 2 squared, x squared with respect. So meaning to say, we can see properly our a squared. This is our a, this is our b. So this is our a, this is our b, and this is our x. So whenever we need a, we're going to write the a that we give a squared, just like what we have there. So it means this was going to be integrated from that formula. So we're going to have the integral of what? Now let's integrate. A squared over 2b. So this was going to be like this. A squared. A squared is the first term. This one, a squared, which is the first term, is what? It's 9. So there's nothing there. So it's 9 over 2 times b. Our b, in this case, b is the coef. This one from b squared. This one, 3 over 2. So it's 3 over 2 like that. So if you are to consider this, guys, from your calculator, you are going to get a 3. If you are to simplify this properly on your calculator, this was going to give you 3. And this was going to be arc sine. All right, so we've got 3 arc sine of bx. So it's going to be bx over a, like this, bx over a. So that is our B. Our B, remember, is what? 3 over 2 from this number. So it's 3 over 2x over A. Our A is given as what? From 3 squared. Our A is what? Is 3. So if you divide properly, 3 over 2, then you divide it to 3. So it must be 3 over 2, like this, divided to 3 is going to give you 1 over 2. So it's 1 over 2x, which is same as x over 2. So it's going to be arcsine x over 2. That's it. Plus x over 2. X over 2 is still the same x over 2. So it's just going to be x over 2 as it is. The square root of a squared, as you can see, this one, a squared minus b squared x squared, is the same as this one that we had previously from our format. So this a squared b minus b, this one, it represents originally your question, the way that it was. So it's 9 minus 9 over 4 x squared. So that's it. With our limits from 2 to from negative 2 up to 2, we were going to have the value of the area, and make sure that your values here are in radians. Whenever you deal with a trigonometric, your values should be in radians. So our area with respect to x was going to be what? If we substitute 2 here, it was going to be 3 arcsine 2 over 2, that's a 1. So it's arcsine 1 plus, if you substitute at 2 on this one, it was going to be 2 over 2, which is 1, then the square root of 9. You're going to see that this one was going to give us 4 squared, because it was going to be 4, and it cancels, and 9 minus 9, which is a 0 there. You're going to get a 0 on this one. And we can't simplify the square root of what? The square root of a 0. So meaning to say even that part there that we are seeing. So meaning to say that there's nothing that we are going to have from what? From the square root of 0. The square root of 0 is what? It's a 0. Or just substitute, guys. Just substitute. It's only that me, I can work by sight. By just looking into the question, I can see what's happening. So you can even substitute, guys. I might shorten the way that you're used to. Just substitute properly. When x is minus 2, so it's going to be 3 here. So you're going to have 3 arcsine negative 2 over 2, which is going to be negative 1. So it's arcsine negative 1. Negative 2 squared is same as 2 squared. So this will give us a 0 also. So meaning to say that's a plus 0 there. There's nothing that you're going to have. All right, so that is what we were going to have at the end. So this is 3 arcsine 1 in radians. Make sure that your calculator is in radians. You have to change these to radians. Then you simplify this part, separate like this. Let me show you guys here. Our calculator, that's shift set up, then radian, which is 4. So that means we've got 3 arcsine. Arcsine is on top of this, so it's shift sine 1. That's arcsine 1 like this. So it's going to be 3 pi over 2, or 3 over 2 pi. All right, so the area with respect to x is going to have 3 over 2 pi minus, we simplify this now, 3 arcsine negative 1. So this is just going to carry a negative this time, which is negative 3 over 2 pi. So it's negative 3 over 2 pi like this. So if you simplify the previous answer, the 3 over 2 pi that we had, minus 3 over 2. If you simplify 3 over 2 minus 3 over 2, you're going to get a 3. So meaning to say our answer will be 3, but having what? A pi. So it's going to be 3 pi in that case. So this is area. So it's going to be 3 pi square units. If you simplify this, 3 times pi in square units, if you simplify as a decimal, it's something like 9.42. You can even fix this to 3 decimal places. That's going to be 9.425. So this is same as 9.425, which is what? In square units. That is the idea there. That is how you could have calculated our area. So the area part, I'm not worried about this because this is our N5. The only part now for area is that the formulas you see, because now we have to use this area, these formulas in calculate. But even in N5, we used this formula. We used it. So there's nothing to worry about. We used this formula. It's a continuation. Okay, so I'm just going to remove some of these other things here that are not necessary for now. So our area, we got our area with respect to x, and that was 3 pi, which gave us 9,425 square units. All right, so that was our area there. Let's see the other part of our question. What is it that we are supposed to calculate now from this function? So you see, guys, it's just a repetition, only that now you have to use this formula, another formula, but it's just a repetition of what we had before. This time they want us to calculate the magnitude now, which is the distance. The distance of the centroid from where? From the x-axis. The distance of the centroid from the axis of rotation, meaning to say we are calculating what? Y bar. From the x-axis, we are calculating Y bar. That is the distance of the centroid. So remember, I say that Y bar is the area moment of the opposite. Now, the area moment for X over the area. We saw that from our formula sheet. So meaning to say, we have already calculated, the area is already calculated, it's there. What we need is this one. The question is not even asking you guys, calculate the area moment for X. No, it's not. It is you, because you're asked to calculate the centroid from the X, because it's from the X-axis, meaning to say we are calculating Y bar. And Y bar is area moment for X. Now that you know that is the area moment for X, it means you have to calculate the area moment for X. So that is where you go back to that information where I said the area moment for X is true. It's very, 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 very true that the area moment for X, for Y, whatever that you're given, it's RDA. It's very true. Very true. It's very, very true. That is what you're given there from your formula sheet, just like this. It's very, very true, which is the integral of RDA, the R that you're going to have, which is the strip. But the strip now, I say, it is affected. The area moment with respect to X, meaning to say the R there is the distance from the X-axis. So R is the distance from where? From the X-axis. So if it is from the X-axis, how do you present a centroid of a circle? We say the centroid is XY, meaning to say, remember there what I said, X bar, Y bar. So X bar, Y bar is the one that we need from the X-axis, meaning to say we need what? Y bar, but Y bar is given as what? Y over 2. If it was the area moment for Y, where X is needed, we are going to take X as it is, but this one is for X. So from the X-axis, the Y that we need is not just Y, but it's Y over 2. So if it is for X, X is not affected, no. It is Y that is affected, Y over 2. So guys, you have to be careful. Which part do you use there? So meaning to say this R here, the distance from the X, which was supposed to be Y bar, it is going to be given as Y over 2. So it's going to be the integral of Y over 2. Then dA is the area expression. What was your area expression? You calculated your area, yes, which is this one. But what was the area expression before? We had the area expression. If you take note, it was the area about the x-axis, where the area was given by the integral of y dx from a to b. The area expression y dx, this one is the one that you're going to use. So it's going to be y dx, which is the area expression. So this is the one that we solved later on, and we obtained half of y squared. If you still remember when I manipulated those formulas, that is the same thing. So meaning to say you're going to take this y out, this 1 over 2 out, the 1 over 2 here. So it's going to be 1 over 2. Remember our limits a to b. So it's going to be y times y, which is left inside. So it's y squared dx. Remember, we had a formula like this for an area moment of this. So you just have to take those formulas. That's how you find it. So you see, it depends with what you're given. And also about what? About the x-axis, about the y-axis. Between the curve and x-axis, if it was between the curve and the y-axis, it means y is the one that is not affected. X is the one that is affected. So it's going to be x over 2. That's the idea. That's the idea for our functions. So meaning to say this y to be we can't integrate y with it's impossible with respect to x. It's impossible to integrate y with respect to x. So y represents what? F of x. Y, it's a function of x. It's a function of x. And remember, from our manipulations there, when we did the manipulations, we had y squared from the manipulation. Remember, we had from that stage before we simplified to obtain y, which is the square. We had y squared, which is 9 minus 9 over 4x squared. That is where we introduce the square root to obtain y. So instead of taking from the square, already y squared is there. What represents y squared is this in terms of both. We need an equivalent. What is equivalent to y squared? What represents y squared in terms of x? It must be in terms of x. What represents y squared, but in terms of x? And this is exactly what we have here. So meaning to say this is going to be 1 over 2. The integral of y squared, or you square that square root, still you get this. But already you have, guys, why do you bother that? Already y squared is there in terms of x. So this is the one that you're going to integrate with respect to x with your limits. Remember our limits a and b. With this diagram of ours, our limits is from -2 up to 2. So that's -2 up to 2. So that's our area moment about x. Just like that. Just like that. So with this, we can calculate the area moment. So this is going to be half of the integral of 9 with respect to x. This is going to be 9x, 9 over 4. So this is, we've got a negative there, but we're going to have 9 over 4 times x squared. So it's going to be, if we add a 1 here, it's going to be x cubed over 3. So you'll see that this one and this one are going to cancel. It's going to be 3 over 4 on your calculator. You're going to get 3 over 4x to the exponent of 3. With the limits from -2 up to 2. That's it. That's the idea there. That's how you simply work out. With these limits that we are given, we can determine our area moment about the x. We were never asked about this area moment, but because of just to calculate what the distance from the x-axis, the area moment, we are forced to have it for x. The formula is forcing us. That is it. So our upper limit is going to be 2 here, minus 3 over 4 into x, which is 2 cubed. So that's it, upper limit minus the lower limit. If x is a -2, so that will be 9 times -2 minus 3 over 4 into x, which is -2 cubed. So that's it, upper limit minus lower limit concept. So you're going to obtain your area moment. So this was going to be half of, you simplify the first part there, you are going to obtain a 12. So this was going to give us a 12 minus, if we simplify the whole of this part here, we're going to obtain a -12. So meaning to say at the end, -12 and minus was going to be a plus, and that is going to give us 24. Half of 24, which is a 12. So this is area moment, and our area moment is measured in cubic units. So that's the area moment for x. That's how you calculate the area moment. So the area moment is something that is limited with a function, the function that you're dealing with. With the function, the x-axis, function, y-axis. Or we are given two functions. There is just a single function that you're considering. So we have the area moment for x. But is it our question? No. The question was never about the area, but because of what you need here, the distance of the centroid, the distance, it now forces us to have this area moment, because y bar is going to be taken from the area moment about the x. So the area moment about the x, which is what? The area moment that we have here. And what is our area moment? We get 12 cubic units. So this is our area moment about x, which is 12 cubic units. So that will be 12 cubic units over the area, which is the one that we calculated previously here. We calculated our area because it's from 5.1. And from this is 5. This is the wall of this part is from 5.1. So the area was calculated there. So depending with what you're gonna use, in this case, whether it's 3 pi or this decimal, but our area is measured in square units. So it means at the end, the square units into the cubic units, gonna left with the units, and that'll be something like 1.273 to 3 decimal places. So this is the distance from the x-axis. The area moment about the x over the area that you calculated before. So it's a conditional type of equation. You need to work with different types of questions. That is what you need. But I explained what you need on those different types. So we're going to work with different types and see how our questions can be given. You just have to relate your information, whether it's between the given functions and the x-axis, the functions, and the y-axis. Each and every part, you're going to see that the centroid differs. This is the most part here, the most important part, this one. How do you take it? So we saw how do we take this? How do you present this like in each part? X, if it is about X, it means X is not changing. Y is the one that is affected, Y over 2. About Y, it means Y is not affected. X is the one that is affected, so it's going to be X over 2, Y. Given different two types of given two functions, x1 plus x2 over 2, y, like that. On this condition, again, you can be given two functions for y, so x is not going to change, but y is going to be y1 plus y2 over 2. That's it. So we are going to have different types of questions, but as you can see, that's your question number 5. That's how you're going to have your questions on the area moment and at the end, calculating the centroid from a certain axis of rotation. So we are going to have different types of questions, more on this type of simplification.